So good morning, class, and welcome to the session. Let's wait for 5 minutes and then we will start. In meantime, others will join.
मग 3 वर्ष गॅप करा पर्सेंट दाखवा आणि मग त्याला मार्कशीट किती असणार पर्सेंट एवढी विषय तुम्हाला शॉर्ट नाही
इतने कम लोग क्यों हैं आज? अगर मैं 8:30 रखता हूँ तो लोग 9 बजे आते हैं। 10:30 रखा था कल तो लोग 11 बजे भी आए थे। रात 10 रखता है तो लोग पता नहीं कभी तो टाइम से आओ। आई थिंक टाइम से आना इज समथिंग नॉट इन योर नेचर इस क्लास का, बट ठीक है। आई थिंक वी हैव वेटेड इनफ, but let's move ahead. Just give me a minute. And actually the topic which I'm going to start is actually very difficult topic, but I cannot wait beyond a point. Okay, so those who have joined online remotely, guys, please confirm if I'm audible.
Yes, sir.
Okay, thanks for quick confirmation, Siddharth. Okay, first of all, tell me any doubt from yesterday's session? PCS related to doubt? No. Please remember all the theory regarding regarding KMEs. Regarding KMEs, remember all the points which we have discussed. It is heavily used in industry, and probably you can expect a lot of questions also being asked in more interviews also. So KMEs was your unsupervised. Okay. It was an example of unsupervised algorithm, but today also the journey for unsupervised will continue. Let's discuss our another algorithm in unsupervised, that is your PCA. PCA stands for your principal component analysis. This is little difficult topic, but one good thing is that probably don't expect much question being asked, and I am more than 99% sure probably you will never use it in your life. ऐसा बहुत ही कम सिनेरियो आएगा यूज करना पड़े, बट आ सकता है. ठीक है. So PCA is again an example of unsupervised. Okay. PCA stands for your principal component analysis. Basically, PCA is, just try remembering few sentences for talking purpose. PCA is your dimensionality reduction algorithm. Dimensionality reduction. Dimensionality reduction algorithm, or dimensionality reduction, or it is used for dimensionality reduction. Answer: it is used for dimensionality reduction. The first thing for PCA is that PCA is not a machine learning algorithm. ये machine learning algorithm नहीं है. It is not a machine learning algorithm. ये ML algorithm नहीं. It is not a machine learning algorithm. It is used for your dimensionality reduction. It is used for your dimensionality reduction. We will see. I know that probably people don't understand what is dimensionality reduction, but we will see what dimensionality reduction actually means. No. So when I say dimensionality reduction, so if you have a data frame, Then what are the dimensions of the data frame? Can I say dimension of the data frames are nothing but your rows and columns? यही तो होता है उसका dimension. Rows and columns. Rows and columns are the dimensions of your data frame. And I'm saying it is used for your dimensionality reduction. So what do you think? Rows will reduce or columns will reduce? क्या reduce होंगे? Rows या columns?
दोनों सो
दोनों होंगे. ओके, ठीक है. So let's keep this question open. मैं इस क्वेश्चन का आंसर अभी नहीं करता हूँ. Let's keep this question open. So when I'm reducing, I'm saying PCA is used for dimensionality reduction. So rows will reduce or column will reduce or both of them will reduce. Let's keep this question open, and soon, let's say next half an hour or 1 hour, probably this question would be automatically answered that which things are getting reduced. Okay. ठीक है. So PCA will always work on numeric data. ठीक है. This is the obvious point. It will always work on your numeric data. ठीक है. Your data has to be in numbers. Now, I am saying it is used for your dimensionality reduction. So PCA uses orthogonal transformation. It uses orthogonal transformation for dimensionality reduction. Okay, you are reducing the dimensions, but what technique or methodology you are using for dimensionality reduction, that is your orthogonal transformation. Now, since I have used the word orthogonal transformation, let's discuss what is this orthogonal transformation. Let's discuss the orthogonal transformation. So in orthogonal transformation, let's say if A is a matrix, if A is a matrix and AT is the transpose, and AT is a transpose. Then what will happen that if you multiply A into AT, then you get your identity matrix. What is transpose? Transpose is nothing but your rows become column. Rows become column and column become rows. So for example, if I say your matrix is something like this, A, B, C, D, E, F, G, H, I. If this is your original matrix, then the transpose would be A, E, I, and I'll say B, C, and D, A, B, C, D, D, E, F, G. So G इधर आ जाएगा, G ऊपर आ जाएगा, और ये F था, राइट? F इधर आ जाएगा और H इधर आ जाएगा. Diagonal will still remain same, but बाकी चीजें shift कर देंगी. Right? Now, I am saying A into AT is equal to identity matrix. But normally A into AT is not identity matrix, but A into A inverse. What is this? Inverse of A. A inverse. A into A inverse identity matrix. A into A inverse is your identity matrix. What is identity matrix? Where diagonal is 1 and all the other elements are 0. All the other elements are 0. So basically, A into A inverse is also I and A into AT is also I. It means AT is acting as inverse. AT is acting as inverse. If AT is acting as inverse, it is known as your orthogonal transformation. If AT is acting as your inverse, AT is nothing but your transpose. If transpose is also acting as your inverse, it is known as your orthogonal transformation. It is known as your orthogonal transformation. So it uses orthogonal transformation for dimensionality reduction. Okay, so what are the few points we have noted? We have said it is not a machine learning algorithm. It works on only works on numeric data. This is the obvious point. It uses orthogonal transformation for dimensionality reduction. And what is the orthogonal transformation? I have just explained. Now let's come to the fourth point. Okay. Let's come to the fourth point. Okay. Now, A into X is equal to lambda into X. ये into का symbol है multiplication. I hope people understand. What is A? A is your n cross n matrix. A is your n cross n matrix. And lambda is a scalar. Lambda is a scalar. It is called as, it is also known as your eigenvalue. It is also known as your eigenvalue. And what is X? X is the, please बातें नहीं करो. X is a eigenvector. जो लोग देर से आए, please start coming on time. हाँ? अब ये टॉपिक तुम्हें समझ में वैसे नहीं आने वाला है, जो लोग अभी आ रहे हैं. X is your eigenvector. जो क्लास में शुरू से होने समझ में आया तो बहुत बड़ी बात है. ठीक है? X is your eigenvector. ठीक है? Again, I'll try to explain what is this. Suppose that A is a matrix. Just an example I'm taking. Let's say A is a matrix of 5 cross 5. And X is a matrix of 4 cross 5. Then if you multiply A into X, what would be the size of output matrix? अगर तुमने A और X को मल्टीप्लाई किया तो X का साइज क्या, तो आउटपुट का साइज क्या होगा? बताओ, कभी तो करा होगा मैट्रिक्स मल्टीप्लिकेशन 9, 10, 12 इंजीनियरिंग. 5/5 पक्का? क्यों? A का साइज कितना है? 5 cross 5. X का साइज कितना है? 4 cross 5. This multiplication is not possible because for multiplication this number should be same. ये नंबर सेम नहीं है तो मल्टीप्लिकेशन वैसे ही पॉसिबल नहीं है. ठीक है, तो तुम्हारा जस्ट एक रिवीजन कर रहा हूं. So this is multiplication is not possible. But let's say if X was 5 cross 5, or let me change the number. Let me say X was 5 cross 6. X was 5 cross 6. Then this matches. Now the output would be 5 cross 6 समझ में आ रहा है सबको? ये कोई मेरा बनाया फॉर्मूला नहीं, बेसिक मैथमेटिक्स है, ठीक है। नाउ दस इफ यू मल्टीप्लाई a and x then the dimension of the output matrix would be 5 and 6. इतना समझ में आ रहा है सबको? Keep this thing in mind and come back over here. Keep this thing in mind and come back over here. What I'm saying, I'm saying A is your n cross n matrix. What is X? X is a vector. X is a vector of size n cross 1. Vector का मतलब समझते हो ना? Vector means in simple terms you can say that it is having just one column. This is known as your vector. Now size of the vector is n cross 1. If you multiply A का size कितना? n cross n, and A का size कितना है? n cross 1. So this thing matches. This thing matches. So now what would be the output? Output would be this and this. The output would be n cross 1 only, which means it would again be a vector only. बराबर? इतना समझ में आ रहा है? If you are multiplying a matrix with a vector, output is also a vector. If you are multiplying matrix with a vector, output is also a vector. What is X? X is a vector. What is lambda? Lambda is a eigenvalue. Eigenvalue, it means it is just a number. It is just a number. अब सब लोग प्लीज यहाँ पे ध्यान से देखो, मैं सिर्फ एक बार बोलने वाला हूँ. A into X is equal to lambda into X. The output, the size of the output would be n cross 1 over here. What is X? The size of the X is nothing but n cross 1. What is a lambda? Lambda is a number. Suppose karo the number is 2.5347 whatever, and if you multiply it by a number, let's say 2, then what would be the output? 2.5 into 2, 4.5, 2 into 3, 6, 2 into 4, 8, 2 into 7, 14. The output is again n cross 1 only. Why? Because lambda is a number. तो अंदर के वैल्यूज उतने से मल्टीप्लाई हो जाएंगे. So if you multiply A cross X and if you multiply lambda into X, the output is same. Output is same. Yes. Now let me say A was your original matrix. A was your original matrix. Then can I say for different values of X, different lambda values would be existing? For different values of X, the lambda values would be different. Okay. So I'll say for different values of lambda, or different values of X, you can say different values of lambda, different values of X would be there. What is lambda? Lambda is your eigen value and X is your eigen vector. So it means for different eigen vector, different eigen values would be there. ये line सब लोग please note down कर लो. For different eigen values, different eigen vectors would be there. For different eigen values, different eigen vector would be there. Okay. So there are, I know that people are not 100% clear with it, but जब हम coding करेंगे तो तुम्हें शायद समझ में आएगा. But let me explain few more things. ये शीट तो पूरी भर गई, कहीं पे लगे है रखने के. It uses orthogonal transformation, and then guys, please make a note down of this. Please make a note of this formula. A into x is equal to lambda into x, where x is your matrix, lambda is a scalar. The scalar is nothing but your eigenvalue, and x is your eigenvector. X is your eigenvector. ठीक है, इसको note down कर लो. Okay, one more point. Let me say fifth point. PCA can also be used when you have problem of multicollinearity. Multicollinearity सबको याद आते हैं? It was one of the assumption that I should have maximum multicollinearity or minimum multicollinearity. So if you think there is a problem of multicollinearity, if x variables are highly correlated, then PCA can be used. But do not use it as a first choice. ये पहली choice नहीं होनी चाहिए. ठीक है? Because PCA is not a machine learning algorithm. You cannot do sampling. तुम sampling नहीं कर पाओगे इस पर. You can do prediction, but you cannot do sampling. यहाँ पे थोड़ा सा supervise का concept change होता हुआ दिखेगा तुम्हें, supervise and supervise. So I would be able to do the prediction, but I won't be able to do the sampling. Sampling possible नहीं होगी. So PCA can be used when you have problem of multicollinearity. ठीक है? ठीक है, I think that's it. Whatever theory we have discussed, it will get more clear when we'll do our coding. You guys do one thing, open your Jupyter notebook and let's run our PCA. सबके पास एक डेटा सेट होगा, प्रॉपर्टी प्राइस ट्रेन डेटा सेट है. प्लीज रीड दैट डेटा सेट. Read the property price trend data set. Okay. ठीक है. So we will build our PCA on this data set. सब लोग जैसे जैसे मैं कोडिंग करता जाऊंगा वैसे वैसे करते चलेंगे. ठीक है. So please write a comment that are you able to see the screen?
No.
No? अरे क्यों नो भाई? PCA on. अब बताओ, दिख रही है? PCA on property files. Now, so basically the data cleaning part will still remain the same. Let's do a data cleaning. अगर data cleaning का कोड तुम लोग के पास है तो please go ahead and use it. If you already have the data cleaning code, PA dot is null. So even I am going to do some kind of copy paste. अपना अपना data cleaning का कोड invoke कर लो. I hope everyone has it, right? Okay, guys, everyone please stop and see over here. सबका डेटा वैसा होना चाहिए जैसा मेरे पास है. So what I've done, I have filled my nulls, whatever, and then I have used my label encoder. Then at the end, I am having 75 columns. I am having 75 columns. Which all columns have I dropped? I have dropped the lane type column, fireplace, pool quality, fence quality, miscellaneous features because they were having huge amount of nulls. And I have also dropped the ID column. So 1, 2, 3, 4, 5, 6 columns I have dropped. Okay. So ID column, obviously you guys have to drop because it is just a unique identifier. Rest other columns, if you don't want to drop, then don't drop it, but I am dropping it. At the end, I am having 75 columns. And none of the columns are having null. So remember this line 222, it will check whether nulls are there or not. So I am getting an empty list. It means there are no nulls. And you run your info function. And info function में सब लोग please देखेंगे your D type. Whether it is your integer and float, none of them should be object type. Again, I am repeating, please be very sure in your data cleaning. Error आखिरी में आएगा. An error would be coming because of your data cleaning and don't expect me to solve it. ठीक है? So I am giving you 1 minute to your data cleaning. Not more than a minute. My assumption or the null hypothesis is that everyone has this code. Reuse your code. डन। कौन से कॉलम ड्रॉप किया, दैट आई कैन टेल यू वंस मोर। द कॉलम्स व्हिच आई हैव ड्रॉप्ड इज लेन टाइप, फायरप्लेस, पूल क्वालिटी, फेंस क्वालिटी, मिसलेनियस फीचर। सो बेसिकली नल्स करके देखो, जहां पे भी 40-50% से नल्स ज्यादा है उनको ड्रॉप कर दो, दैट्स इट, सिंपल। एंड ड्रॉप योर आईडी कॉलम। डन, सबका हो गया। Okay, now should we do sampling? Sampling तो करनी नहीं है, but do you notice one thing, that this data set also contains your target variable sales price. I need to get rid of this. So what I'll do is, अब सब लोग बिल्कुल वैसा ही करेंगे जैसे मैंने करा। Take, create a copy, PA1 is equal to PA. So create your this copy after your full data cleaning. So what I've done, I have taken a backup of your data. PA1 is equal to PA. Later on, this backup would be used. Now what I'll do is I'll say boss PA is equal to PA dot drop. What is the name of my target variable? Name of my target variable is sales price. Get rid of this variable. Just get rid of this variable. X is equal to 1. Now PA dot shape. It is 74. I don't have a target variable. I don't need a target variable. Is it done? यार एक लाइन रन करने में कितना टाइम लगता है? What about those who are joined online?
Done, sir.
Done.
Done. Okay, ठीक है, fair enough. Now, so till this point, what we have done a data cleaning. Now let's start with the PCA. अब PCA actually start हो रहा है. Now PCA is starting. So I'll say, guys, please code along with me. So I'll say from sklearn, import decomposition. From sklearn dot decomposition, import PCA. And please make a note, P, C, and A, all of them are caps. Import your PCA. Also from sklearn dot preprocessing, import standard scalar. Import your standard scalar. So all these are your necessary import. From sklearn, import decomposition. From sklearn.decomposition, import PCA. From sklearn.preprocessing, import standard scalar. Imported and let me know. Guys, done? Can you move ahead? Okay. Now, so standard scalar. Remember, तुम लोग को दो चीजें याद हैं? How to standardize or how to make your data unitless. So one formula was your x minus mean divided by your st. याद आता है? X minus mean divided by st. So probably the same formula is being used in your standard scalar. And there was another formula, x minus x min divided by x max minus x min, x max minus x min. ठीक है ना? So what I will do is, please make a note that before doing your PCA transformation, you will always make your data unitless. You will always make your data unitless. So what I'll do, I'll say scalar equal to standard scalar. I'll create an object of it. Scalar equal to standard scalar. And then I'll say scalar dot fit transform. Scalar dot fit transform, and I'll pass my PA data, and I'll store it in my scaled PA. Acha, before, no, it is not just fit, it is fit transform. It is fit transform. Guys, do you notice one thing? When I was using my label encoder, then also I was saying fit transform. याद आता है? Fit transform किया था ना? So what does fit transform does? It changes your data. So same thing, I want to transform my data. I want to make my data unitless. So what I'll do, I'll run this thing. Now you check your scaled PA. If you check the shape would still be same. But the data would have become unitless. So if you run your head function, okay, so it has been converted. I think it has been converted into an array format. So can you notice पूरा data change हो गया? Can you notice some minus some numbers in minus some number in plus? So ये कब आता है? When you have used your x minus mu upon SD. ठीक है? So what I have done is I have done my standardization. Fit transform कर दिया and store it in the variable. Take a minute and let me know. Guys, can you move ahead? Online folks, please बताओ सबने यहाँ तक करा?
Yes, sir.
Okay, so always one person is answering in online. What about others? बाकी लोग जो हैं?
Yes, sir.
Yes, okay, ठीक है. ठीक है. So if people have done, let's move ahead. So again, let me repeat. Basically, till this point, in a way, we haven't done anything related to our PCA. Data cleaning, and then we have transformed the data. But soon we are about to start a PCA. Let's say next slide. So I have already imported PCA, and let me say PCA. I am creating an instance of PCA. PCA. Create an instance, and then what I'll do, I'll say PCA. Dot fit transform. Which data I'll transform? I'll transform this scaled PA. And let me say PA PCA. Or let me say data after PCA transformation. So this will give you more clarity. Let me take a little bigger name. Data after PCA transformation. Done. So what is this capital PCA? I hope people can connect to it. You have already imported this PCA function. You are creating an instance of it, and then you are doing your fit transformation. Remember, eigenvalue, eigenvector, orthogonal transformation. And after your PCA transformation, what I am doing, I am storing the data in the data after your PCA transformation. Now, when I run the shape function, how many rows, how many columns do I have? 1, 4, 5, 9, and 74. Before PCA transformation also, these many rows and these many columns. So has the dimensionality reduction taken place? क्या dimensionality reduce हुई है? Remember मैंने क्वेश्चन पूछा था क्या कम हो जाता है रोज या कॉलम? तो क्या कम हुआ? कुछ भी नहीं हुआ ना? So same number of rows and same number of columns. So till this actually reduction has taken place, but हमें पता नहीं चला, अभी पता चलेगा. So at this point you will notice that same number of rows, same number of columns are there. ठीक है? But what is the name of my model? Name of my model is PC_PA. Let's explore. So write one line that PCA transformation has been done. इस लाइन पे हमारा PCA हो चुका है. Now whatever I am trying to do or whatever we will do is to understand what has happened. हुआ क्या है वो आप समझने की कोशिश कर रहे हैं. जो होना था वो हो गया. इसको हटा दो. Come to this thing. PCA explained variance ratio. कुछ खास है इन नंबर्स में? अच्छा, I'll just help you out. I'll say इसको तुम लिस्ट फॉर्मेट में देखो जरा. Check it in the list format. Then probably you will be able to see the numbers more clearly. Do you observe anything in these numbers? अगर एक छोटे बच्चे को भी दिखाएंगे तो भी आंसर आ जाएगा कि क्या है. Do you notice? Do you find anything in these numbers at line number 239? Values start decreasing. So can I say it is in descending order? So it is starting from a high value and it keeps on decreasing. So very good observation. Values are decreasing. Or I'll say it is in better word would be descending order. ठीक है. Descending order में कुछ और भी तो ऑब्जर्व हो रहा है. जो मन में आ रहा है सब बोलते जाओ. राइट और रॉन्ग. Don't worry about it. Can I say that all the values are positive? सारे numbers positive हैं? Do a scrolling. All the numbers are positive. Can I also say that all the numbers are less than 1? सारे के सारे 1 से छोटे हैं. I'll say less than 1. Positive हैं and they are less than 1. It means they are between 0 and 1. All numbers are positive and they are less than 1. So it means they are between 0 to 1. And ये numbers हैं क्या? They are the explained variance ratio. यहाँ पे देख रहे हो ये वर्ड आ रहा है रेशियो. एंड रेशियो इज ऑलवेज लेस देन 1. ठीक है. अगर हाईएस्ट को तुम 1 मान लो देन रेस्ट एवरीथिंग वुड बी लेस देन 1. है ना? नाउ Let's do one thing. Let's take this thing and do the sum. Do you notice that sum is nothing but 1? 0.99999 is nothing but 1. It is nothing but 1. So sum of all the ratios has to be 1. चाहे यहाँ पे हो चाहे कहीं पे भी कर लो, sum of all the ratios has to be 1. Because if you are dividing it by the biggest number and if you add all the ratios, it has to be 1, right? It has to be 1. Now, that as you go down, then the values are almost close to 0. So for example, this is nothing but e minus 33. It is 33 zeros after decimal. This is 32 zeros after decimal. This is 0.00. This is 0.00. Can you notice somewhere, if I take 2 zeros after decimal, it is starting from this point. And उसके बाद सब के सब zeros होते जा रहे हैं 0.009 or 0.00 whatever, right? They are almost consistently zeros. How many numbers are we having over here? यहाँ पे कितने numbers हैं? कोई guess कर सकता है? 74 ही होंगे. $74 number. How many columns did I had? 74. It means for each column there is one number. It means for each column there is one number. Right now, for each column there is one number. Acha, remember one thing, when we used to build a decision tree and random forest and I used to do feature importance, then also the sum used to come as 1.
Right.
One other, and the higher the value, more important was that feature. Higher the value, more important was that feature. Are you getting my point? Something like that is happening over here. Okay. See, now, what is this PCA explained variance ratio? What is variance? Variance is nothing but a representation of your randomness. Acha, R square yaad aa raha hai? What does R square indicates? If R square is 0.7, then what does that 0.7 means? It is able to explain 70% of the variance, correct? Now, consider that your total variance or the total randomness is 1. Then your first principal component is able to explain 0.1284 of your variance. Second principal component is able to explain 0.05. Third one is able to explain 0.048. Fourth one is able to explain your 0.09. Or if I say that total variance is your 100%, then first principal component is explaining your 12.84. 0.1284 को अगर हम 100 से मल्टीप्लाई करेंगे तो इतना ही होगा ना, 12.84. This one would be 5.36, right? Acha, remember yesterday in K means what we have done? When you increase the value of K, the SST will keep on decreasing. But I used to stop where there was a sudden downfall and values stabilized because there was no point looking further. Now, in any model, if I say in any model, there would always be some error. कुछ तो error हर model में रहेगी. No matter whatever you do. In any model, there would always be some error. Let's say around 5 to 10%. Around 5 to 10% error would always be there. So basically what I can do is, we can select those number of PCAs which are able to explain around 90 to 95% of the variance. Around 90 to 95% of the variance. And we can ignore rest of them. We can ignore the rest of them. Achha. Now, I know that people have not bought into my idea. लोगों को ये idea ज़्यादा पसंद नहीं आया है कि भाई क्यों ignore कर देना, लेकिन मैं तुम्हें वो idea पसंद क्यों आना चाहिए वो बताता हूँ. Let's take another example. This time, I am taking an example. I am deviating from our PCA. Suppose karo. Let's take a very simple example which you guys will always understand. Let me say you want to predict the MPG of a car, miles per gallon. So probably, let me say you take the weight of the car, which is suppose the, then you say horsepower, correct? Then you say your fuel type. And then you also take up whether it is automatic or manual. Okay, fair enough. Let me say you also take it as number of gears. Using these 5 significant features, X1, X2, X3, X4, and X5. So you are using these 5 significant features and you are already getting your R square as somewhere around, let me say 0.87. And let me say adjusted R square is somewhere around 0.86. Okay? Now, weight, horsepower, fuel type, whether it is automatic, manual, whatever. But there can be other features also. Now, you said, let me add some another features also. Let me say number of carburetors. और कौन से फीचर्स हो सकते हैं guys? Number of cylinders. Number of cylinders. Okay. और सोचो कार में कौन से सिग्निफिकेंट हो सकते हैं? Which one? अच्छा हाँ चलो, फ्रंट व्हील ड्राइव और रियर व्हील ड्राइव. फ्रंट व्हील और रियर व्हील. ठीक है, फ्रंट व्हील और रियर व्हील. और लेट मी से यू आल्सो इंक्लूड द मेक, whether it is SUV or sedan, let's say. ठीक है ना? You also take. So all these variables, let me say carburetor, cylinder, front wheel, rear wheel, SUV, sedan. Suppose you are adding X6 also, X7 also, X8 also, and X9 also. Now, see guys, number of carburetor and cylinder already have something to do with your probably number of gears or number of or your horsepower. Horsepower तभी ज़्यादा होगा जब cylinders ज़्यादा होंगे. Correct? So in a way, when you are taking cylinder, when you're putting cylinder, something related to cylinder was already there in your model, horsepower, right? Front wheel, rear wheel drive, probably it's a new thing, or SUV or sedan probably again has something to do with your horsepower or weight or whatever, or gear, right? Suppose you add these 4 more variable and your adjust R square was 0.87, and after adding these 4 more variable, your adjusted R square becomes 0.874. It will increase. Let's say it increases. You are adding 4 more variable and R square increases. And let me say adjusted R square is almost same. Zyada kuch problem nahi aata. It is still, let's say, around 0.86 or whatever. Okay, let's say. Do you think that adding these 4 variables makes sense? इनको क्या add करना चाहिए? You are making your model very complicated. You are adding variable, but model is not improving at all. It is improving, but the rate of improvement is very less because your model is already on the very higher side. 0.87 तो वो ऐसे ही आ चुका है. And the maximum value it can be 1. Suppose करो तुम्हारे 87% marks already है. now increasing of marks would be very slow. So basically, if you are hell bounded to add these four variables, go ahead and add them. But the better way would be just ignore them. Your model would be a lighter model and business decisions can be taken easily. So what I can do is I can just use these 5 variables and still go ahead and build my model. Prediction would be easier, model would be built faster, and it would be more interpretable. अब सबको ये समझ में आ रही जो मैंने लाइन अभी बोली? What did I say? I said in any model there would always be some error around 5 to 10%. We can select those number of PCS which are able to explain around 90 to 95% of the variance, and we can ignore rest of them. If I add all of them, I am able to explain 100% of the variance. But why should I take all 74 principal components? I will take those number of principal components which are able to explain me around 90 to 95% of the variance. Variance is nothing but in a way kind of representation of your randomness. अब कोई बता सकता है कितने नंबर्स को ऐड करने पे 94 या 95 तक आ रहा है? प्लीज करके बताओ. Starting from the top, add them. So do one thing. Let's do one thing. देखते हैं. एक काम करते हैं guys. देखो. Let's do one thing. Let's put it in a list. L1 is equal to list. ठीक है. L1 is equal to list and L1, and if I say 0:30, so पहले के 30 select कर लेगा ना, then इस पे sum function चलेगा. सम नहीं चल रहा. ओके ठीक है, नो प्रॉब्लम. ये नहीं चल रहा पर ये तो चलना चाहिए. np डॉट सम. So if we do some, so first 30 principal component are explaining your 0.7232, and then I can do some kind of trial and error. 40 are explaining this much, 45 this much, 50 this much, let me say around 55. So the first 55 principal components are explaining me 0.94, or you can say it is around 95. So if I build my model, using my first 55 principal components, then can I say I have done the dimensionality reduction? Instead of using all 74, if I use only 55, then can I say I have done the dimensionality reduction? हाँ या ना? Dimension reduce कर दिया. So do you notice towards the end the values are almost close to 0. They are explaining very less amount of variance. तो उनको लेने का फायदा ही क्या? Right? They are explaining very less. So what I've done, I hope people understand this type of thing. So 0:55, it means first 55, right? Okay. So it will go till 55, but will not include 55. But since counting started from 0, it is also, in a way, it is 55 principal component. Okay. So if I build my model using first 55, or if you don't want to use even 55, if you want to use only 50, then it is explaining your this thing. So there is no hard and fast number. If you want, you can take 56 or 55. So I've taken 55. So if I build my model using first 55 principal component, then can I say I have done the dimensionality reduction? Can I say I have also done the feature selection? Yes. अब यहां पे सब लोग हो गलत. अभी पता चलेगा भाई. पहले तो इस लाइन को नोट डाउन करो. PCA can be used for dimensionality reduction, but PCA cannot be used for feature selection. It cannot be used for your feature selection. And mark my word, cannot. अगर तुमने बोला using PCA you can do feature selection, तो वो totally wrong statement होगा. It would be a completely wrong, which means तुम्हें PCA समझता नहीं है. ठीक है? PCA cannot be used for your feature selection, which means you cannot identify which feature is important. And एक तो बड़ा obvious answer ये है, how can you say feature is important? Target variable तो था ही नहीं. तो किस sense में importance? Remember sales price तो पहले ही हटा दिया था. PCA cannot be used for your feature selection. PCA cannot be used for your feature selection. And guys, why? See, okay, now tell me, which was the first column in your this data set? First column in this data set was your building class after removing your ID column. So what do you think? Building class is the most important one? क्या मुझे पहले से पता था कौन सा वेरिएबल सबसे इंपॉर्टेंट होने वाला, उसको मैंने पहले ले रखा था? और was zone class the second most important one? क्या मुझे पता था? नहीं पता था ना, तो फिर वो इस ऑर्डर में क्यों दे रहा है? See guys, remember one thing, in PCA what has happened, if I tell you something like this. Acha, tell me one thing, is everyone getting the almost similar numbers which I am getting? Provided your data cleaning is also same, then your numbers and my numbers would be matching. Match करते हुए दिख रहे हैं? Almost match करेंगे. ये random process नहीं है. This is not a random process. Now see guys, remember what has happened. So for example, let me take an example. आप सब लोग ध्यान से देखना कि why it is not a dimensionality reduction. So for example, what were your name of the columns? Name of your columns were, let me say few names of the columns. So paint window दिख रहा है? So let me say your building class, your zone class, lot extent, and lot size. I'm just taking 4. Okay. Suppose this was your data. And then you had a data something like this. Zone class, lot extent, building class. और कौन सा बच गया? Lot size. So do you notice, let's say this is your data frame 1 and this is your data frame 2. In data frame 1 and data frame 2, the only difference is that I have shuffled the columns. Rest all the data is same. Imagine all the data is same. Then also after your PCA transformation would still be same. इतनी चीज समझ में आती है? PCA transformation would still be same. Now if PCA transformation is still same and you are getting value something like this, you are getting 0.45 and let me say 0.15 and let me say you are getting something like this 0.7 and you are getting 0.2, then you are getting 0.06, 0.04. You add all of them, you get answer as 1. But you cannot say that 0.7 is mapped to your zone class or the building class. Because column का order कुछ भी हो, तुम्हें PCA same ही आने वाला, चाहो तो करके देखो. Why? Because in your PCA you have done the transformation, you have done your axis rotation. कभी वो चीज सुनी axis rotation? So let's say if this is your thing, you rotate your axis rotation हो जाता है, and this would shift somewhere over here, right? Now any point on this line would be consisting from your this thing also and your this thing also. So your access transformation has been done, right? So using your PCA, you cannot do your feature selection. You can only do your dimensionality reduction. इतना सबका समझ आ रहा है? ठीक है? Your data has transformed. इसको कुछ ऐसे भी notice करो guys. If I explain you in different terms, suppose करो you have some numbers. Let me say you have a number 10, 11, 20, 25. ठीक है? Or you have a number 11, 25, 20, 10. So if you apply x minus mu upon SD on this number and x minus mu upon SD on this number, the outcome would be same. The 10 की जो वैल्यू यहाँ पे आएगी वही 10 की वैल्यू यहाँ पे भी तो आएगी. आ रही बात समझ में ना? So similar kind of thing is happening in your this thing also. So the order of the column doesn't matter. ठीक है? Now can we go back to our coding panel? सबने इतना लिखा? Please मैं बार बार बोल रहा हूँ, PCA cannot be used for your feature selection. It can be used only for your dimensionality reduction. Now, let's build the model using our first 55 PCAs. Let's build a model using our first 55 PCA. After a PCA transformation, हमारा data कहाँ पे store हुआ है? Where is our data stored? Remember, मैंने एक proper name दिया था. Not PA1, data after PCA transformation. इसीलिए इतना बढ़िया नाम दे दिया था ताकि तुम लोग confuse ना हो. And if you check this thing, it would be having how many columns? It would be having 179 and 74. ठीक है? Now guys, do one thing. Dot. If I run the type function on this, if I run the type function on this, you will notice it is a array. It is a array. For doing a prediction, our data needs to be in data frame. याद आता है भाइयों बहनों? So हम क्या करेंगे? इस array को data frame में convert कर देंगे. Let me say df1 is equal to pd dot data frame. Convert कर दो इसको data frame में. Data frame में convert हो गया. From sklearn. Now from here onwards you don't need my help. From sklearn dot, I'll go a little fast. Linear model. Import linear regression. Let me say I want to build my linear regression. Linear reg equal to linear regression. अरे सब लोग सिर्फ यहां तक करेंगे and they will wait. Don't do anything else. Don't do anything. Just wait at this point. Done? Now, अच्छा, remember for building my linear regression, I need my x and y. Y तो हटा दिया था, but remember मैंने y हटाने से पहले उसका एक बैकअप ले लिया था. अब उसका समय आ गया. ठीक है? जिसने बैकअप नहीं लिया होगा वो प्रॉब्लम में आने वाला है. Now, everyone stop whatever they are doing. So how do I build my model? I take this thing and I give my fit and then I give my x comma y. Am I right? I give my x comma y. So from where would I get my y? To get my y, what I'll do is I'll say PA1. I'll say PA1 dot sales price बराबर. X कहां से आएगा? X will come from your DF1, but I want to use only first 55 columns. So what I will do is I'll say DF1. I'll say DF1 dot ILOG. I want to use all the rows, but only 0:55. Model build. समझता है सबको? So x comma y. If you want to score your function, so this is, what is this value? ये value किसको indicate करती है? Guys, ये किस चीज की value होती है? R square. Yes. It is nothing but your R square. And I think सबकी value same आएगी. सबका इतना आ रहा है? अच्छा. So I hope people understand 0:55. 0:55 means you are using first 55 columns, correct? Now, अब सब लोग वापस ध्यान से देखो. Let me build my model this and this. So instead of using 0:55, if I remove this thing, it means I am using all the 74 columns. जब 55 यूज करें तो 0.84, जब सारे यूज करते तो देखिए कितना आता है 0.85. कितने का इंक्रीमेंट हुआ? 0.01 का समथिंग. और व्हाट आई कैन डू इज लेट्स सब्ट्रैक्ट these numbers. This minus this 0.0062. So is there any point using all those columns? Right? Is there point using all those columns? So basically I can build my model using first few principal components. ठीक है? But एक और चीज हो रही है जो अभी शायद नोटिस नहीं हो रही है. प्लीज मेक अ नोट. एक लाइन लिखो सब लोग. In your PCA, the first principal component is always the most important. I repeat my statement. In your PCA, the first principal component is always the most important, followed by the second one, followed by the third, so on and so forth. In PCA transformation, the first principal component is always the most important, followed by the second one, followed by the third one, so on and so forth. पहला प्रिंसिपल कंपोनेंट सबसे इंपॉर्टेंट होगा. समझो वो भगवान है. And the best way to understand is, guys, again have a look. Now, if instead of 0, if I say 1, it means I am ignoring the first principal component. Correct? पहले वैल्यू कितनी थी? 0.84. अब जरा देखते हैं कितनी हो जाती है. देख रहे हो? From 0.84, it has come down to 0.11. Model has gone for a toss. तो तुम कुछ भी कर लो, पहले वाले को कभी नहीं हटाना. So the first principal component is always most important. So when you do your counting from 1:55, from 0.84, the value goes down to 0.11. So around 70-80% का decrement आ जा रहा है. 73% down हो गई value. Or you can say several times it has gone down. Is the thing getting clear? Now let's do one thing. अगर मैं यहाँ पे 2 से काउंटिंग करूं तो देखें क्या होता है. और कम हो गया. अब देख रहे हो? The first one is most important, followed by the second, followed by the third. And this thing is very prominent or predominantly. You can see over here also. है ना? पहले को तुमने हटाया तो मॉडल गया, बैंड बज गया. Now, अच्छा remember, while discussing a theory, मैंने एक statement और बोला था that PCA can be used if you have a problem of multicollinearity. Now, first of all, tell me what do you mean by problem of multicollinearity? तुम बताओ, Mr. Cat. There is a strong correlation among my X variable. There is a strong correlation among my X variable. Where are my X variables? Can I say my X variable are in DF1? DF1 here, तो है ना मेरा X? Because this time your Y is in PA1. अपने DF1 को explore करो और बताओ. Explore your DF1. आंखों से देखो और मेरे को बताओ क्या हो रहा है उसमें. Any observations, guys? कुछ करा तुम लोगों ने उसको देखने के लिए मल्टीकोलिनिटी? अच्छा चलो, df1 डॉट co r. I hope people understand this is nothing but a correlation matrix. इसको देखो अच्छा तुम लोग और बताओ। सपोज करो कोई नई चीज दिख गई है तो उसको अच्छे से देख डालो और बताओ। प्लीज वो मत बोलना डायगोनल वन होता है, डायगोनल हमेशा वन होता है, कुछ और बोलो उसके अलावा। वो भी सही, वो भी सब में होता है। इट इज सिमेट्रिक अराउंड द डायगोनल। कुछ और भी तो देखो, बहुत चिक चिक के बोल रही है मैट्रिक्स। चिक चिक के बोल रही है। कौन सा फर्स्ट एलिमेंट? डायगोनल तो हमेशा वन होता ही है, उसमें कौन सी नहीं बात है। डायगोनल इज ऑलवेज वन, whether it is this matrix or whether I'm building correlation matrix from this data or any other data. कुछ और देखो, नोटिस करो, बहुत प्रीडोमिनेंट है, सामने सामने दिखता है, कुछ दिमाग लगाना ही नहीं है।
नेगेटिव वैल्यू।
कहाँ नेगेटिव है? So correlation can be negative. What is something special in that? Overall correlation matrix में क्या खास दिखता है? Diagonal R1, it is symmetric around the diagonal. This is in general. DF1 में क्या खास दिखता है? तुम लोग को अब टी ब्रेक ले लेना चाहिए। Can't you notice that almost all values are zeros? देख रहे हो? -16, -16, -16, 17. देखते हो? What is -16? -16 mean after decimal you are having 16 zeros. So for example, if I take this value, I am copying this value, and if I multiply it by, तब ये 0.30 आती है, 0.31 आती है. It means this value is nothing but close to 0 only. E -16 का मतलब समझते हो ना? So if this value is 0, it means correlation between your this column and this column is 0. If this value is 0, then correlation between your first column and second column is also 0. If this value is 0, then the correlation between this and this is also 0. And what are these? These are nothing but your x. ये x ही तो है ना? Because df1 is nothing but your x only. If correlation between your x variable itself is 0, then how come multipolarity can come? If correlation among your x is already 0, then multipolarity cannot occur. कोई और प्रॉब्लम तो हो सकता है, बट मल्टीपोलरिटी का प्रॉब्लम तो हो ही नहीं सकता, बिकॉज कोरिलेशन इटसेल्फ इज 0. सो कैन आई से दैट योर पीसीए कैन ओवरकम द प्रॉब्लम ऑफ मल्टीपोलरिटी? ठीक है, अपार्ट फ्रॉम डायगोनल एलिमेंट एवरी अदर थिंग इज 0 ओनली, तो मल्टीपोलरिटी आ ही नहीं सकती. ठीक है, इतना समझ में आता है सब लोगों को? Write down one line. Correlation between any two principal component is always 0. Correlation between any two principal component is always 0, बिकॉज वो ऑर्थोगोनल ट्रांसफॉर्मेशन है, 90 डिग्री पे है, तो उनका कॉस 0 हो जाता है. Correlation between any two principal component is always 0. Correlation between any two principal component is always 0. ठीक है guys, now take a break. Take half an hour break. PCS done. It is 11:45. Let's meet at 12:15. ओके गाइस, सो अब नेक्स्ट क्या करना है? Give me a minute. Okay. See, so did people try on this thing? So remember I said that PCA cannot be used for your feature selection. ठीक है ना? किसी ने ट्राई करके देखा, कॉलम से शफल करने की कोशिश करी? किसी ने ट्राई किया या खाली बैठे थे? अच्छा देखो, सब लोग प्लीज यहाँ पे देखो. Let's do one thing. Let me read my file once again. मैं कोड को ऊपर से रन करते हुए आ रहा हूँ. I'm running from the top. Okay. Info. Now, PA.shape is this thing. Null is this thing. So at this point, let me just put one more line. So if I say PA.head, so which is the first column? Building class है, right? Or let me do one cleaning. PA.1 sales price drop हो गया, shape, ठीक है? I did my PCA transformation on PA. Sales price and everything is removed. इस line की जरूरत नहीं है. Let me say I put the same thing over here. Put the same thing over here. So PA.head. And let me see, just drop two records. So which is the first column? Last column? Sales condition. Okay, na? Now, what I'll do is, I'll just shuffle my data. Shuffle the data means I will shuffle the columns. So क्या करता है? PA dot shuffle or PA dot sample, and I will say frac. Okay, so frac equal to 1, comma access equal to 1. Do you notice the columns have been shuffled? अब ध्यान से देखो, I am going to run this code number of times. हर बार कॉलम चेंज होते हुए दिख रहे हैं? हर बार कॉलम चेंज होते हुए दिख रहे हैं? दिख रहे हैं? Let's do one thing. Take any one of them and store it in your this thing. ठीक है? And I will not run this code. Let's first copy these numbers so that I can do before and after comparison. The numbers were these. ये numbers हैं, इनको यहाँ नीचे डाल देते हैं. ठीक है? So column को मैंने क्या कर लिया था? Shuffle कर दिया था, right? Now let's run them. Do you notice the numbers are still same? 0.1284, 0.0536. इस बार column तो change कर गए. Column change means the data is still same. The first column may be at your 10th position, the 10th column may be at your second position or whatever, right? But do you notice your PCA explained variance ratio is still same? It means there is no one-to-one mapping between your variance ratio and the original column. And that is why I'm saying you can do dimensionality reduction, but not your feature selection. Okay? Please करो, वो line add करो. Add it at the logical place. अच्छा, before you add it, let me explain this line. इस लाइन को ध्यान से देखो, ये कर क्या रही है गाइस। सपोज करो मैं इसको हटा देता हूं। सो फ्रैक इक्वल टू 1 मींस फ्रैक्शन इक्वल टू 1 मींस आई वांट टू shuffle my entire data. If I do not give access equal to 1, if I do not give access equal to 1, then it will shuffle only the rows. अगर मैं access equal to 1 दे देता हूं, it will shuffle your column. जैसे ड्रॉप करते टाइम हम access equal to 1 दे देते ना, so अगर access equal to 1 दिया, it means it is shuffling your column. And if you don't want to shuffle your column, if you only want to shuffle your rows, just remove this access equal to 1. Are you getting my point? So next time अगर तुम्हें सैम्पलिंग करनी है ना, तो तुम ऐसे भी कर सकते हो। इसको ले लो, इट विल शफल योर डेटा। सपोज करो एक ताश की गड्डी है, प्लेइंग कार्ड है, बट इफ यू शफल देम, then whether you pick a card from the top or from between or from bottom, probability of drawing any card will remain same. Correct? So if you shuffle them, then it is kind of your random sampling only. If you shuffle them and if you take top 80%, then it can be taken as your train. ऊपर के 80 उठा लो, it would be taken as your train. Last के 20 उठा लो, it would be taken as your test. Or if you take top 20, you can take it as your test. Last के 80 as your train, because you have already shuffled your data. ठीक है? Now please go ahead and add your access equal to 1. Remain same. जूनियर वाला मर गया ना, अमीर आदमी कैसे मर सकता है? इलाज नहीं कराया। इसने अभी भी तो नया एयरलाइंस चालू किया था, बैठनेस पहले ही चला गया। But 62 is not that. वाला अब उसके बच्चे लड़ेंगे उसकी वेल्थ के लिए, ज्यादा पैसे कमाना भी प्रॉब्लम है। बहुत ज्यादा वेल्थ है ना। जिस हॉस्पिटल में इलाज करा रहा था उसको खरीद सकता था, तभी मर गया। ओके। हॉस्पिटल के साथ डॉक्टर वॉक्टर सब खरीद सकते थे। ओके, अब नेक्स्ट क्या करना है? हम्म एक डेटा सेट है ना, एम्प्टी कास्ट, प्लीज रीड दैट डेटा सेट. चलो, रीड किया सबने? पक्का? So your empty graph data set would look something like this, correct? So let's do one thing. I want to discuss another algorithm, next algorithm, that is your clustering algorithms. K-means is also a clustering, but I want to discuss this thing. I want to discuss your hierarchical clustering. Hierarchical clustering. What is hierarchical clustering? Though it would not be much used because it is these type of clustering don't make much sense on a very large data. But yes, you can, if you want, you can still do them. So what is hierarchy? Hierarchy क्या होता है? Generation. So top level, then second, then third, then fourth, then fifth, right? Hierarchy. Parent child कह सकते हो, लेकिन parent child पे child का child, right? Something like that. Hierarchy, right? So same type of thing can be, we can do our hierarchical clustering, right? So basically you start with a small group, then you divide it, then you further divide it, then you further divide it, then you further divide it. So India के अंदर state के अंदर फिर city, फिर ऐसे लोग divide होते चले जाएं, right? So that is your hierarchical clustering. So and the theory of hierarchical clustering is very simple. If I can just show it over here, hierarchical clustering. So at the starting, let me say your clusters would be, suppose you have 100 records. Suppose you have 100 records. At the starting, you have all the 100 records. At the starting, you have all the 100 records. And then you divide it into a cluster. So let's say this is your A, this is your B, this is your C. And then they get divided. And this one again gets divided. This gets divided. This gets divided. This gets divided. Or whatever. And on your y-axis, let me say, this is the distance. And this keeps on branching. Let me say this keeps on branching. We have number of branches, right? So over here, the distance is least. And over here, the distance is, let me say, maximum. Okay. So when the distance is maximum, then almost all the points would be in a same cluster. जो point दूर का भी होगा वो भी same cluster में आ जाएगा, right? So for example, let me say over here it was one cluster. Let me do the thing something from below also. Let me say this was A, B, C, D, E, F, G, H, and then it became I, then it became J, became K, L, M, N, O, P. Okay. So if you look from the top, you can say I am decreasing the distance. If you look from the bottom, you can say I am increasing the distance. If distance is very small, then number of clusters will keep on increasing. So if I say all the points which fall under 100 meter, then number of people in 100 meter would be more compared to number of people within my 10 meter, right? So if you keep on increasing the distance, then the clusters will keep on adding. Clusters will keep on adding, and you would have a big cluster with number of records. And if you keep on decreasing the clusters, you will have many clusters with less number of records in it, right? So I can say, let me say this distance This distance was 10 units. This was, let me say, 25 units. And this was your 40 units. I'm just saying units because I don't know whether it is centimeter, meter, whatever, jo bhi hai. And this was, let me say, 70 units. So at 70 unit, so if you are saying distance as 70 units, then all the points are same because they fall under the same cluster. ठीक है? अगर किसी को अभी भी समझने में प्रॉब्लम आ रहा है तो let me take one example. If I say the income, and if I say if the income is from 0 to 10 lakh, all the people who are from income from 0 to 10 lakh, they would be forming one group. So probably in this class, everyone forms one group, leaving me. मेरे को छोड़ दो, मैं तो पढ़ा रहा हूँ, ठीक है? Because अभी तुम सब लोग 0 से 10 लाख के बीच में हो. But suppose करो किसी की जॉब लग गई है, और let me not say 10 lakh. Let me say 0 to 1 lakh. सब लोग एक ही ग्रुप में होंगे because as of now no one is doing any job, everyone is studying. But let's say after 2 months someone has got a job. So probably now there would be two groups. एक तो 0 to 1 वाला हो ही गया, एक greater than 1 वाला भी हो जाएगा because जिसकी जॉब लगी होगी उसकी सैलरी obviously 1 लाख से ज्यादा ही होगी पर annum. So now as you, so what is this 1 lakh or 0 lakh? It is nothing but kind of distance. इसको थोड़ी देर के लिए distance मान लो. So as you keep on increasing the distance, but instead of 1 lakh, if I say 10 lakh, then again this person would belong to the same group क्योंकि हो सकता है उसकी 10 लाख की ना हो, 5 लाख की हो, 8 लाख की हो, 9 लाख की हो, 9.99. So when I am increasing the distance, the records or the points which are far also will start to come in your same group, right? And as you decrease the distance, the number of clusters will increase, but the records per cluster will decrease. And this type of clustering is known as your hierarchical clustering. Hierarchical clustering. Are you getting my point? इतना समझ में आ रहा है? There is no more theory in this. This is known as your hierarchical. Code करके देख ले. And we'll try to draw a diagram also. सबने इतनी चीज रीड करी? Let's do one thing. Let's drop our MPG column. Drop. And MPG is kind of my target variable. Let me say I don't have a target variable. MPG को drop कर दिया. Give me a minute. ठीक है. इस बार थोड़ा सा डिवेट कर रहे हैं. Instead of using sklearn, probably I'm going to use my SciPy. So I'll say from SciPy dot cluster dot hierarchy import. क्या हो गया? Import dendrograms. Import dendrograms. एक सेकंड दे, हम लोग एक फंक्शन इंपोर्ट करना है, कुछ समझ में नहीं आ रहा कहाँ से इंपोर्ट होगा। यहाँ से ना एक लिंकेज फंक्शन इंपोर्ट करो, import linkage also. So basically I would be using my linkage, and then let me say z equal to linkage, and what I'll do, I'll give my empty cars. Okay, so now see, basically what I've done is, if you read this function, what is linkage function? So basically it uses your Euclidean distance, and it finds the distance between each and every record. It finds your distance. So z dot shape. So shape is your 31 and 4. So it is finding your distance. So basically you can say that over here I am performing my hierarchical clustering. Hierarchical clustering has been done. Now clustering has been done, but the only thing is it is little difficult to analyze it. So I'll say plt.figure in matplotlib. Fixed size equal to 10 cross 10. Then I'll say plt dot just अगर dendrogram plot कर दें, dendrogram, and let me say that plot होता है, plot तो होता है, can you notice एक plot आता हुआ दिखता है? So dendrogram. So this type of representation इसको बोलते हैं dendrograms. So p equal to 12, and then I'll say truncate mode. Truncate mode equal to last p. Truncate mode equal to last p. And what I can say plt dot title. Title में क्या डाल सकते हैं? clustering plt.x label. plt.x label will tell you the cluster size. plt.y label will tell you the distance. Okay, I will tell you the distance. ये हो रहा है. Okay. Achha, now, guys, let's see what is happening. So, do you notice what is this P? What is this truncate mode doing? The best way to understand is कि उसको बार-बार run करके देखो. So, for example, when I have given, मैंने P यहाँ पे 50 डाला है, और इसके नीचे के आउटपुट को देखो कैसा आ रहा है. The numbers change हो रहे हैं, numbers छोटे-छोटे हो रहे हैं. Suppose मैं इसको यहाँ पे 12 डाल देता हूँ. So, this is just for your kind of your font, you can say. Can you notice? It is changing, right? So the way you want to control your number. Now, what is happening with your truncate mode equal to last P? Suppose करो मैं ये नहीं देता हूँ, तो कोई change दिखता है? This and this. अगर कोई change नहीं दिख रहा है, change दिखता है, right? So that is what your truncate mode is. So what does truncate means? Truncate means to end. So it will end. So all these are beautification parameters. If you want, you can add them. So it is basically giving you the numbers. Now, at the end, तुम लोग को कितने numbers दिख रहे हैं? कहाँ तक numbers जाते हुए दिख रहे हैं? (31) तक दिख रहे हैं? Can you see the maximum number is 31? 31 दिखता है? 39? ध्यान से देखो 31 भी दिखेगा. देखो ना, ये 31 दिखता है.
31.
क्या किसी को 31 से ज्यादा भी दिखता है? ध्यान से देखो, हो सकता है दिख रहा हो. 31 पे आके क्यों रुक गया? 31 पे आके क्यों रुक गया? 50 पर रुकता समझ में आता था, हाफ सेंचुरी हो गई. 100 पर आता तभी समझ में आ रहा है. 31 पे इसलिए रुक गया बिकॉज उसमें टोटल नंबर ऑफ रिकॉर्ड्स ही 31 है. एंड डू यू नोटिस एट over here the distance is 0, or you can say distance is least. When distance is least, the number of clusters would be maximum. Are you getting the point? When distance is least, the number of clusters would be maximum. And when your distance is maximum, so maximum distance around कहाँ तक जा रहा है? 900 point something तक जा रहा है, right? Remember, it is stopping below 1000. So the maximum distance between any two records is your 1000. So at around 950 distance, if distance is around 950, then all the cards are same. इसका ये मतलब है. If distance is around 950 or whatever, then all the cards are same. Now, do you notice the first division is coming around 400? एक काम करता हूँ ना, इसको मैं पेंट विंडो कर देता हूँ, then people will understand. ये कैसे आएगा? पेंट विंडो पे आ जाएगा. अब आएगा? पेन विंडो दिख रही है? अब पेन विंडो विजिबल दिख गई? अच्छा, नो सी. So now probably explanation would be quite easier for me. So this is your 1000. So this distance may be your what? This distance would be between your 800 and 1000. But ये half mark से ऊपर दिखता है. It is little bit more than the half mark. So probably you can say it would be somewhere around 950, 940. So if distance is around 950, then all 31 cars are same. They belong to the same group. दोनों सब में कोई फर्क नहीं. Now, at this point, around point number 400, there is a first division, and you have probably two categories. एक ये वाली category आ जाएगी और एक ये वाली category आ जाएगी. Then around 200, at this point, you have one cluster, second cluster, third cluster, fourth cluster, fifth cluster, sixth cluster, and seventh cluster. It means when distance is 200, you would be having 7 clusters. फिर जैसे जैसे distance कम करते जा रहे हो, break होता चला जा रहा है. And when the distance is minimum, and minimum distance 0 हो सकता है. Do you notice you are having each car is itself a cluster. ठीक है? So this type of representation is known as your hierarchical cluster. ठीक है? सबको आइडिया आया ये क्या इंडिकेट कर रहा है? ठीक है, अब एक काम करो, सबके पास के मीन स्मॉल वाला डेटा है जो कल दिया था. रीड दैट फाइल, डू द डेटा के. अब तुम्हें रंग बिरंगे प्लॉट बना के दिखाते हैं. क्लस्टर तुम्हें दिखेंगे जैसे चांद तारे दिखते हैं. पुणे में देखा बहुत दिनों से चांद तारे दिखे नहीं. I hope people are dropping this customer ID column. कल सबने ड्रॉप किया था पक्का? जिसने ड्रॉप नहीं किया उसने मिस्टेक करी, बिकॉज कस्टमर आईडी अगेन इज अ just a sequence number, so you should get rid of this column. Okay, no. सबने यहां तक किया? डू द सेम थिंग ऑन योर मॉल स्टिकर. Done, guys? अच्छा, now what is? देखो, the best way to understand is let's change. इसका documentation चलो अच्छा पढ़ते हैं क्या है. दिया नहीं इन्होंने. अच्छा, basically ये जो p है, let's do one thing. Let's try changing this. What is p is equal to 10 or 12. So run before. So इसकी values को change करके देखो, देखो कैसा आता है तुम्हारा diagram. So let's say from 10 I directly go to 30. So before with 10 this is my kind of output. 30 पे कैसा हो जाता है? So it is showing you more, तुम्हें more clusters में दिखा रहा है, right? Suppose करो मैं सिर्फ 50 कर देता हूँ. So it is showing you till 50 I guess. 50 है, उसके आसपास का कुछ नंबर दे रहा होगा. ठीक है. Suppose you do it to 100. It is taking some time. जितना ज्यादा दोगे उतना ज्यादा उसको कैलकुलेशन करना पड़ेगा. Okay. So give some logical number how many clusters you want to see. Suppose मैंने यहाँ पे 12 दिया. And if I don't give, let me say last P. So if you do not give last P, do you notice आखिरी में कैसा दिखता है data? So last, so if you do not give this thing, truncate mode equal to last P. It means at the end, it will truncate. Okay. So that is the, all these are your, these are not doing anything different in your model. These are just your add-on parameters. तुम्हारे diagram को थोड़ा beautiful बना देता है. ठीक है. अच्छा अब देखो, यू आर आस्किंग व्हाट इज दिस p इक्वल टू 10 और 12, ठीक है। सपोज करो मैंने p दे दिया है 4, समझते हैं? कैन यू नोटिस एट द एंड देयर आर 4 क्लस्टर्स, 4 लाइंस दिखाता है, 1 2 3 4। नाउ लेट मी से आई गिव 10, जरा काउंट करो आखिरी के लाइन, 10 है, 10 है, 10 क्लस्टर्स दिखा रहा है, ठीक है ना। सो दैट इज व्हाट इट इज टेलिंग, ठीक है, दैट इज व्हाट इट इज टेलिंग, ठीक है। सो डोंट बी मच बॉदर्ड अबाउट इट, सो वेदर यू वांट टू टेक 10 12 व्हाटएवर, वो तुम्हारा थोड़ा सा चॉइस है जिसको दिखाना है, बट what I want to showcase over here is something more. Import करो सब लोग from sklearn.cluster, import agglomerated cluster. So whenever I am using sklearn, I always create an object of it. ठीक है ना? So agglomerative clustering, create an object. So now what is the name of your model? Name of your model is clusters. इस cluster में कौन सा data डाल दें? Clusters में डाल देते हैं, एक सेकंड यहाँ पे देख लेते हैं default value कितनी है. Default value is n cluster equal to 2, so it will create only 2 clusters. So what, if you want, you can change it to 3, 2, whatever. I'm saying by create your 3 clusters. Okay. अभी कल हम लोग ने करा ना, remember? N cluster के means में भी we can control. So an agglomerative clustering, the default number of clusters are 2, but I'm saying create 3. Now what I'll do is in this clusters, मैं अपने malls के data को डाल दूंगा. बस काम हो गया. अच्छा ये तो वैसा है ना, तो इसको क्या करना पड़ेगा हमें, clusters dot fit and predict. So I am doing fit and predict. So I am saying n cluster equal to 3. So it will create 3 clusters 0 1 2. एक काम करते हैं यहाँ पे थोड़ा सा 4 कर देते हैं, let me say. So it is creating 4 clusters. What would be 4 clusters? 0 1 2 3 0 1 2 3. बराबर. And then I am doing my fit and predict. So what does this, what are these numbers means? And I think सबका prediction same आ रहा होगा जैसा मेरा आ रहा है probably. What does this number 3 means, guys? This number 3 means your second record of your mall data is part of your 4th cluster, which is labeled as your 3. This 0 means your 3rd record is part of your 1st cluster, which is known as your 0th cluster. ठीक है ना? Now, इस डेटा से हमें कोई ज्यादा खास इंफॉर्मेशन मिलती है क्या? कुछ ज्यादा समझ में नहीं आता. Now what I can do is let's plot them. Let's plot them and see how clusters are distributed. अच्छा guys, let me do one thing. अच्छा अब सब लोग प्लीज थोड़ा ध्यान से देखो यहाँ पे, जो भी कोडिंग कर रहा है उसको थोड़ा सा देर स्टॉप करो. Suppose this is your data. I have record number A, B, C, D, E, F. Screen नहीं दिख रहा. Suppose you have A, B, C, D, E, F, G, H, I, J. Suppose को तुम्हारे पास ऐसे records हैं. ये तुम्हारे records हैं, ठीक है? And I am saying, and I am forming 3 clusters. I am forming 3 clusters, and I am saying record number A, C, and D are in one cluster. So A, C, and D हो गया. Then I am saying E, B, I, and J are in another cluster. कौन कौन सा E, B, I, and J are in another cluster. And अब कौन सा बच गया? F, G, H. They are part of your 0th cluster. They are part of your first cluster. They are part of your second cluster. ठीक है ना? Now, if I plot the data, plot as in scatter plot. अगर मैं इसको scatter plot कर दूं, then if A, C, D are one cluster, then point A, C, D should be somewhere close. Otherwise, उस cluster का मतलब ही क्या होगा? And then E, B, I, J. Then these points, they may be over here, they may be over here, but they should be together. These 4 points should be together. So let me say E, B, I, and J. ये एक group बन जाना चाहिए. And then same thing, let me say F, G, H. They should come together, right? तभी तो cluster formation हुआ. Now keep one thing in mind. This is just a representation. So हो सकता है ये वाला group instead of this, the group may be formed over here, or this group may be formed over here. That is something different. But all the points within the group should be nearby. Then only I can say it is a cluster, right? So cluster formation has already taken place, but now let's represent this on your diagram. हम इसे diagram में represent कर सकते हैं, and that diagram will give you some more clarity. But now the question is, when I'm doing a scatter plot, I will take something on my x-axis, something on my y-axis. बराबर? In your malls data set, how many columns do you have after data cleaning? कौन कौन से नाम लो? एक हाँ. पहला कॉलम gender. So okay, so gender, male and female. Okay, next column, age, annual income and spending scope. In your plot, you can take only 2 columns. Out of these 4 columns, which 2 columns should I take? Should I take gender on x-axis, age on my x-axis, or annual income or spending? अगर तुम कॉम्बिनेशन लगाने बैठोगे तो बहुत सारे कॉम्बिनेशन हो सकते हैं. 4C2 के कॉम्बिनेशन हो सकते हैं. Now suppose if you have 10 columns, तो तुम्हें प्रॉब्लम आएगा कि कौन सा कॉलम x पे, कौन सा y पे. तो कैसे पता लगाओगे? एक बड़ा सिंपल सा तरीका है ट्रायल एंड एरर. You can plot, you can take anything on your x, any on your y, but plot, try various combination and see which one is giving you the better result. ठीक है ना? There is no fixed answer to it. ठीक है? इतनी चीज सबको समझ में आ रही है? So again I am saying my cluster formation has already taken. Now I want to represent my data on my graph. थोड़ा दिखने में अच्छा लगेगा. कर लें guys? Just one line of code and then my job comes to an end. सबने matplotlib import कर रखा है? So what I'll do, I'll say plt dot scatter. Scatter plot कर लो, और if you want you can just say plt dot plot. Then I'll say mol dot कौन कौन से कॉलम्स हैं? mol dot head. Income. So mol dot income comma mol dot score. अच्छा, so I am plotting income and score. बट इससे ये पता चल रहा है कौन सा क्लस्टर ए का पार्ट है, कौन सा बी का पार्ट है, कौन सा सी का. अच्छा, रिमेंबर व्हेन वी आर डूइंग अ मैटप्लॉटलिब वी हैव एडेड अ लेजेंड. सब लोग प्लीज याद करो, अपना मैटप्लॉटलिब वाला कोड ओपन करो. रिमेंबर वेडनेसडे नंबर ऑफ पीपल विजिटिंग योर वेबसाइट, मंडे ट्यूसडे वेडनेसडे. सब लोग प्लीज एक बार वो लोग चेक करो, लेजेंड वाला पार्ट याद आ रहा है. सो मंडे वाज डिनोटेड इन योर रेड कलर, ट्यूसडे याद करो. वैसे इस डायग्राम में तुम्हें कुछ 3-4 क्लस्टर फॉर्म होते हुए दिखते हैं, 4 छोटे छोटे झुरमुट. नाउ ओनली थिंग इज आई विल जस्ट से देम. अच्छा, क्लस्टर्स डॉट लेबल्स. गाइस एक सेकंड सब लोग प्लीज स्टॉप योर कोडिंग. Remember your K means clustering yesterday? In K means clustering, if I want to see which record falls under which cluster, how did I found it? कैसे find किया हमने? Did I use the labels? याद करो theory. This used to tell me that which record falls under which cluster. Yes. Current memory refresh हुई. So the same thing you can see over here. So when I say cluster dot labels, it tells me which record falls under which cluster. ठीक है? What is clusters? Clusters is the name of your model. And dot labels. Can I say line number 364 is clear to everyone? Yes. Now, basically your color coding should be done based upon your cluster label. All the records which fall under cluster 0, they should be taken as some different color. All the records which fall under class 3, they should be taken as some different color, right? So what I'll do, I'll say color, do your color coding C. I'll say C equal to cluster labels. Let's see what happens. C equal to cluster label. देखो 4 अलग कलर आते हुए दिख रहे हैं. 4 अलग कलर्स आते हुए दिख रहे हैं. And if you want, you can change the color also. I can say C map. C map equal to rainbow color डाल. Okay, so this is how your clusters look like. This is how your clusters look like. 4 different clusters. Now, and then there are few points which are probably थोड़ा सा overlap भी दिखता है. Decision is little tough. And if you want, you can build the same type of plot on your K-means also. Exactly यही वाला कोड डाल दो. क्लस्टर्स के नाम चेंज कर दो. क्लस्टर के नाम K-means से ले आओ and use this. तुम बताओ इस मैप को देखने के बाद क्या बोलोगे? Let me say you have created this map, you have created this plot, and you want to explain to your customer. या अपने किसी साथी को समझाना चाहते हो तो क्या बोलोगे? बस इतना ही. Last person. This is a graph. What would you say on this? किसी को एक्सप्लेन करना होगा तो क्या बोलोगे? कोडिंग में तुम्हें प्रॉब्लम आता है, बट चलो एक्सप्लेनेशन में बताओ. पर कोड तो तुम्हारे सामने है. अगर तुम्हें समझ में नहीं आ रहा है किसी को ग्राफ, तो उसको प्लॉट करने का फायदा क्या है? वैष्णवी, you tell me. You have got this beautiful plot. What would you say on this? थोड़ा तो दिमाग लगाओ तुम लोग प्लीज। अगर इस ग्राफ को किसी को समझाना है तो कुछ तो बोलोगे ना। तो क्या बोलोगे कि what does this graph conveys to you, or what meaning do I get from this graph? Yes. Which cluster? Now let him complete and then I'll come to. That's it. और कुछ नहीं। वैसे नहीं, तुम बताओ। Yes. 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 So तुम ब्लू किसको ले रहे हो? You are taking this one as blue? मुझे तो समझ में नहीं आ रहा। So which is on the right hand side? वो ब्लू है या रेड? वो क्या है? वो ब्लू है या ग्रीन है? नहीं तो blue। अच्छा टॉप, अच्छा टॉप, टेल मी अबाउट द टॉप राइट। जो येलो, इसको येलो बोल सकते हैं? हाँ, येलो। येलो वालों के बारे में क्या बोलोगे? यस गाइस, सीखो उससे। उसने एटलीस्ट दिमाग लगा के कुछ तो बताया और सही बताया। दिस इज व्हाट इज एक्सपेक्टेड। डू यू नोटिस ऑन विच व्हाट आई हैव टेकन ऑन माय एक्स एक्सेस? ऑन एक्स एक्सेस इनकम आया होगा और वाई एक्सेस पे स्कोर आया होगा। एंड इनकम एंड स्कोर क्या तुम्हें ऑलरेडी बताया हुआ है? व्हाट इज इनकम, व्हाट इज स्कोर? सो based upon your income and score you have done the plotting, and there are 4 clusters. And how does your plot looks like? पूरी क्लास में सिर्फ एक ही इंसान का दिमाग चला, एक लड़की का। So on your x axis what do I have guys? क्या है x axis पे? Income. On y axis what do I have? Expenditure score. Expenditure score means how much the person expends, right? So for these people which are marked in red, do you notice their score is high but income is less? बड़े खर्चीले टाइप के लोग हैं। So probably let's say you are the owner of the mall. So for these people you can design a strategy. Their income is not very high but their spending is very high. तो तुमको कुछ अलग टाइप के प्रोडक्ट सजेस्ट करोगे। What about these type of people which I am marking in yellow? Their income is also high and expenditure is also high. जितना महंगा सामान है सब इनको बेच दो। अच्छा कमा भी रहे हैं और अच्छा खर्च भी कर रहे हैं। ऑडी मर्सिडीज सब बेचो इनको, ठीक है। What about these people which I am marking in? Income is high but expenditure is less ना। expenditure score तो यहाँ से आ रहा है ना। So probably they are rich people but probably they will not do much of the spending. तुम ज्यादा सामान बेचने की कोशिश करोगे तो उतना सक्सेस नहीं आएगा। What about these people? इनकी इनकम इज ऑल्सो लेस एंड एक्सपेंडिचर इज ऑल्सो लेस। एक मॉल ओनर के लोग ज्यादा किसी काम के नहीं है, ना ज्यादा इनकम है ना ज्यादा खर्च करते हैं, कोई फायदा नहीं है टारगेट। समझ में आ रहा है कैसा इंटरप्रिटेशन करना है? अब बताओ मुश्किल था तो कहाँ गया दिमाग? ठीक है, दिस इज हाउ यू विल इंटरप्रेट। ठीक है, And similarly, guys, over here, keep one thing in mind. When you are plotting, you can take only one thing on the x, only one thing on your y. So I'm not saying that you take income and score. तुम चाहो तो gender and score को भी लेके कर सकते हो, तुम्हें पता चलेगा मेल एंड फीमेल में स्पेंडिंग पैटर्न क्या है। यहाँ पे जेनर को लेके देखो क्या होता है, देखो कैन क्या हो गया जेंडर। जीरो एंड वन, तो जेंडर से कुछ ज्यादा मीनिंग कन्वे नहीं होगा। तो यू नीड टू गिव ट्रायल एंड एरर, कुछ और लो। एज से कुछ होता है क्या, देखें। एज जितनी कम होती है आदमी उतना खर्चीला होता है, सिंपल तो यही है, फ्लक्चुएट करता है। स्पेशली हम लोग जनरेशन को देखेंगे तुरंत छोड़ दिया। आउटलायर्स नहीं कहेंगे उसे, बट प्रॉब्ली वी कैन नॉट टेक अ प्रॉपर डिसीजन बेस्ड अपॉन द एज। सो एज एंड स्कोर का कोई फिक्स रिलेशन नहीं दिख रहा है। एज और एक्स एक्सेस पे है, सो एक्स एक्सेस पे ये, सो इनकम किसका, स्पेंडिंग, लेकिन तभी भी तुम देखो स्पेंडिंग स्कोर ना, स्कोर 40 तक ज्यादा है, उसके बाद फिर कम हो जाता है। So if people are of less age,
Sir, screen
then
not
they are
visible.
likely to spend more. Now their income may be less, that is something different, but they are likely to spend more. So जिनकी एज कम है उनका स्पेंडिंग स्कोर ज्यादा है, तो उनको तुम बहुत सारा सामान बेच सकते हो। Obviously they may not buy a very high end products which are very expensive because they may not be earning that much, but yes. And score, जैसे जैसे एज बढ़ रही है स्कोर इज गोइंग डाउन। बियॉन्ड 40 तो कोई ज्यादा खर्च कर ही नहीं रहा है। ये थोड़ा इंटरेस्टिंग है यार।
इनकम से भी कंपेयर कर सकते हैं इसका।
यस, इन ऑनलाइन समवन वाज सेइंग समथिंग गाइस। ठीक है, so basically what you can do is you can build your this type of scatter plot. Do you notice one thing? This scatter plot has nothing to do with your hierarchical clustering. It can be built on your k means also. So वहां पे करना क्या है, जहां पे हमने क्लस्टर लेबल्स डाला है वहां पे तुम k means के लेबल्स डाल दो। Are you getting my point? सबके पास k means, people have built your k means yesterday, right? Try building your k means also. K means का plot build करने की कोशिश करो on this, ठीक है ना। Only change would be coming, instead of cluster labels coming from your hierarchical clustering, put it from your k means, ठीक है ना। देखो क्या होता है वहां पे। Yes, yes. कहाँ पे एरर आ रही है, एरर मैसेज। इसकी स्पेलिंग चेक करिए, अंडरस्कोर दिया है। एक काम करो, ये चीज प्रिंट हो रही है, वर यू एबल टू सी द आउटपुट? लाइन नंबर 364 का आउटपुट आया था। हाँ, तो उसको कॉपी करो और यहाँ पे डालो। And I hope people understand one thing, that there is no right and wrong answer. Guys, सब लोग please एक second यहाँ पे देखो. I hope people understand one thing, that whether you want to take cluster number 4 or cluster number 5, that is something your choice. ठीक है, तुम कितने ग्रुप्स बनाना चाह रहे हो? ठीक है, how many groups you want to make? तुम जितने ज्यादा ग्रुप्स बनाओगे तुम्हें उतना ज्यादा अलग पता चलेगा, बट if you are making many groups, then decision making will become tough. ठीक है, because for each group you may want to have a different strategy. Okay, so decide the groups logically, take 4 groups, 5 groups, don't go beyond that.
Yes, sir. नहीं करता ना एग्लोमरेशन सब्जेक्ट लागते एवढं
ठीक है guys, so try करो, and I think that's it from my side for today. And If you want, you can try on some another data sets also. अगर है तुम लोग के पास. तो आई थिंक मंडे को क्लास नहीं है ना, कल क्लास नहीं, राइट ना, एनीवे क्लास होनी भी नहीं चाहिए. और सो लेट्स, ठीक है, विल मीट ऑन फ्राइडे, है ना, एंड नथिंग एल्स फ्रॉम माय साइड. आई एंड द सेशन. थैंक यू फॉर ज्वाइनिंग.